Okay, so I did some looking shit up last night. Also, I fixed some things, as we can see here. Ignore the bottom sides for now. The top is what matters. And as you can see, some of the seam issues are solved. It's probably hard to see on the actual screen, but this is what it is. So of course I can turn it up a bit brighter so that we can see. So there are some seam issues still. That's kind of to be expected with such a low resolution like this, and also with it only being one pass with very few rays, so that is what it is. So I think moving forward, we're gonna need to do dilation a little bit, which I'm gonna have to figure out how to do that. I don't really know how, to be honest, because my old method of dilation, I don't think it ever really worked. So I think that dilating will probably help the stuff in the cracks. I think something that would immediately help us would be actually to go to where we create that texture and just turn it to nearest, just to see how that would look if the seams go away, because ultimately those seams are just it's linearly interpolating with just empty pixels that are below the other ones. So moving on here though, we are going to, so as you can see, the seams go away with nearest. There are like a few really small minute things, but it's an issue with the linear interpolation. It linearly interpolates with black texels that are off of the thing. So this looks a lot better. In fact, this is pretty much what my whole engine looked like, was this kind of pixely thing. So but anyway, so I have to fix that. Maybe an easy fix, maybe a hard fix, I'm not really sure. Something else that I realized though, and what we're going to be working on for a big portion of today, I feel like, is that this ray marching code doesn't actually work in our BVH space. So that's another thing, is that this ray marching code, you do it in a different way for when you have the BVHs like we have a scene BVH and then a per mesh BVH, so they're on top of each other. What instead you do is you do intersection tests with the ray itself in the node AABBs, and so you don't actually step in any direction ever, right? So that's what this is, that I took notes on earlier. What I also realized in doing the research on this is that our BVH isn't really like truly a BVH, because we duplicate the triangles and don't change the AABBs based on the triangles. So I think that I'm going to go back and I'm going to rewrite this to be what it was in the first place, actually. So yeah, we're going to rewrite this to be what it was in the first place, which kind of drives me up a fucking wall, to be honest, but that is what it is. So the BVH indices, if we can remember back, the BVH indices was originally that massive array that we that we had initially, like this massive array of size t's that we sort as we go down. But I got rid of it for the duplication, which at the time made sense, but now I'm realizing that I misunderstood. Instead of doing this, you're just supposed to find split pause and then order it based on split pause, and then split down the middle, and then only then you size your AABB over all of the bounding boxes of the triangles. So I didn't really understand that at the time, and so I went ahead and I did all of these alterations. When what I should have done is just read more, as is usually the problem with me. The good thing, though, is that we compute the centroids all here, so it's really not like a huge change that we have to do. All we have to do is revert to what we had before. And let me see if I have it still. I might not. I do have the subdivide scene BVH still goes based on that logic. So that's good at least. So let's get rid of this. I'll leave this one commented out just so that we have it for later. So instead of going for the meshes, we want to go for the faces and BVH indices. Let's just leave a pointer here since it's nice and neat. Yeah, I thought that, and I really regret that. My bad. And we don't have to worry about this. We don't have to worry about translation since it's local. And so instead of ABBs intersect, what we're supposed to do is what I did in the beginning, which is if we're supposed to get the centroids, which we get based on AABB's BVH indices I. And then if AABB center dot x is less than split pause. So I misread it, is basically what happened. I misread it. Because you're only supposed to resize it after. You only use split pause to get it, and then later you resize it. So it's a bit of stupidity by me. In reality, the code is supposed to be a lot simpler than what I ended up with. So that is a bit stupid of me. So now what we need to do is this left count and right count. Well, it isn't stupid of me because the example I had this left and right count when it doesn't really make sense to have left and right count if we're just splitting down the middle. It doesn't make sense. So you just split the list in the middle itself. Yeah, I don't think that you do this. I was trying to figure out if that's the case, but I don't think so. I hope I'm not becoming lactose intolerant. That would suck. I think you just split down the middle. No? I think that's what you're supposed to do. So instead of going by I, you just go you just do this to split it down the middle. And then you resize the ABB based on all the tries inside of it. Okay, so we get our... We can't use I because we already have it, so we're just going to use J. We already have J, so we're going to use K. Okay. Moving on. Something else I have to do is we have to always, well, actually no, we have to initialize the left child dot ABB equals dot yeah, let's just do this. We can wrap this in a function later. I just want to get it down. We need to get the AABBs themselves. And instead of BVH indices I, it will be K. Okay, we're not going to do this. just so that we don't have to write that out every time. Love your content. It's awesome. 12 a.m. in India right now. Thanks so much. I hope you're having a good day. I really appreciate that. Just working on some acceleration structures. You know how it is. All right. This is kind of painful, but that's all right. Once we do it for the left, then it'll just be copy and paste for the right. I should really make it its own function, but we're just gonna pretend that it's fine. All we're doing right now is we're making it so that we're just making it so that at the end of our sorting for the BVH, now we're just making the bounding boxes exactly the bounding box of the triangles inside of it. So that's all we're doing. Should I switch to Linux as a beginner? I'm in cybersecurity domain. Definitely. The only reason I'm on Windows is because my computer doesn't really play well with Linux. Because it's a Windows computer. It's one of these like Surface Books. So it's running Linux on this thing kind of sucks, to be honest. Just the drivers don't work. But yeah, I think Linux just for development in general is just way better. Way better. It's just so much easier too to use. It's like not even close. Okay, so now we resize the AABBs afterwards. The question is, we probably want to recalculate the center. So, we can do this fairly easily by going left AABB center equals like 3. And we'll just write it out like this. We want to do ABB left ABB XX minus left A. Actually, let's do this. I already have this this code. Don't I have compute AABB from points? Calculate AABB extents. That's exactly what we want. We already have a function that does it. Alright, so we're going to calculate that for left and calculate that for right. Now the question is, how do we know when we're... Well, this is going to break everything, first of all, but the leaf indices at the bottom are always going to be fine. Yeah, so instead of this, we can just do this. I don't even think you need leaf indices. I think that it just points to the left and the right. The question is, How do I know when to exit out now? I think that this is the heuristic to figure out to exit out. HL. Because this is what I read. If HL equals 0. Let's just try that. The problem with if we get rid of leaf indices is that we have to change everywhere we refer to this to not reference leaf indices. Like our collision or everything. What's up, Crab? So for now I think I'm going to leave this. And all this will do is that it'll literally just push it onto an array. It should be the exact same thing, just more memory. Alright, so let's see where we're set faulting. Let us see. Okay. A, B, B, and subdivide mesh try BVH. 1505. BVH indices I. Hold on a second. We never actually set BVH indices here. So mesh BVH indices I equals I. That needs to get initialized to that. Okay. Now 1618. Okay. BVH indices K. Well, it does you just have no idea what it is. In World of Tanks, my ass is on fire. It's fucking insane. Damn. That sounds intense. That does sound intense. We can print it out, whatever this is. I'm just trying to see. Left child first index is parent first index. Left child count equals left count, which is the parent count divided by 2. Oh, wait, hold on a second. It's just parent count divided by 2. That was giving us a negative. Doobie-doo. Okay, there we go. And it seems to be fine. We still aren't traversing it properly. I'm going to assume that, yeah, we don't have collision. And how do we fix that? Well, that's going to be hard. I don't know why we don't have collision, actually. Oh, because all of the tries are in here. Isn't it? Let's just try doing this. Okay, there we go. Okay, we still have some problems. See, this was the problem that I had with the... Oh, because I didn't do this. I didn't do it based on the different axes. Okay, we still are falling through. Okay. We can print out the yeah, infinite loop. Infinite loop. Instead of this, what we're supposed to do is not change parent count and parent first index and parent index. We're not supposed to change this. And what we're instead supposed to do is reference the BVH indices using our stuff here. Let's just make sure that this is correct. Parent count divided by 2. So we go parent first index, left count, then the right child first index is parent first index plus left count, should be fine. And then the right child left count is parent count minus the left count. That should all be fine. Let's bring back the depth counter. I think that that's important. But let's just get rid of all of this. And then, since we're only caring about the collision code right now, because we have to change that, let's just go and find that. Where we traverse it. We traverse it here. So instead of using leaf indices, we're going to use BVH indices, and that's literally going to be it. Now I don't know if that's where it's breaking. I have a feeling that it actually has to do with the BVH construction itself. Why are we crashing? We had a great fight. Damn. That sucks. Damn. That sounds intense. Let's see. $267 in Raycast World when going based on mesh indices. Yeah. It's the light map. While we're working on this, let's just turn off the light map actually. And in our frag shader, let's just set it to the normals again. Fuck. Okay, so now we're not getting any collision whatsoever. So that's really, really, really not good. Yeah, I have no clue about any of that. I'm pretty ignorant to war sims, I guess. Personally. Yeah, I didn't really. I kind of wanted this to just work today. I didn't really want to have to fucking go through it right now, but I think that that's where we're at with it. We have this code here that kind of does it. All I want to do is render the AABB. Obviously, this whole stuff is going to have to be replaced with mesh. I'm just going to put in offsets of 0, 0, 0. All I want to do is render these ABBs so that we can fucking move on with our lives and find whatever the bug is. This is useless. Redefinition of nodes. Well, it's not useless if it does that. We need to make them white. So that I can see what's going on. I mean, obviously, this just made them pink, but okay, I think I see what the problem is. The AABBs are just too restrictive. They're just really, really tight. Like, huh. Well, maybe not, actually. They seem to be fine. actually. Like, that they're sized correctly. I wonder why we aren't generating collisions then. Maybe the tree is fucked up somewhere. Yeah, we just hit an infinite loop here. So that just means that the problem is probably traversal. Damn, that sucks. I'm sure you were very annoyed at him for standing around doing nothing. Yeah, maybe I should have just stayed with my other structure. Now this is like kind of fucked. I think I build it fine. It's just hold on a second. Oh no, this is the mesh ABB. This is something interesting. Why does the mesh ABB not here? Oh, I only print out the leaves. That's why. I'm surprised that this doesn't get collision because this is like these are pretty flat. Like I could see how our point might go through it. But here I got like a little bit of collision. Huh. I'm gonna assume that we just don't find the correct nodes. We can do a printout here for it. God, I did not want to work on this today, to be honest, but it's necessary. I just need to know found node. Oh. No node found. I don't think it matters since they all go through the BVH indices anyway. So even if you don't hit a leaf, it still should get you somewhere. Still should get you somewhere. K plus node first index. Yeah, that should work. Unless it's this point in AABB way of going about it. Maybe it is traversal at the end of the day. Man, I kind of regret going down this rabbit hole right now. Not gonna lie. If I do like really shallow depth, do we traverse it right? Then we at least get some collision. Maybe I need to Google how to traverse this with a point. But I mean, it should just be... Don't I have a traverse BVH function? I do. Maybe I should be calling it. No definition found. That's fucking bullshit. What do you mean no definition found? It's right here. This does the same thing. When it should be a recursive function. Let's do the recursive version of this. We're just gonna do the... Yeah. We want to check against our current node. Oh, you do need nodes because of the... Yeah. But the node is the one that we're currently on. It's kind of confusing. That is what it is. Do you just return a... Do you just do this? Something like that. Something like that. Let's see if we can do something like that. Alright, so we made it recursive instead of being flat like it was. Can we fucking chill, bro? Like, seriously. Just don't compile this file. Just don't compile the file. Just, like, legit, just comment it the fuck out. Are we serious? Like, dude. Just don't compile it. Okay. Are we fucking serious? Okay. Oh, hold on a second. That's supposed to be that. Yeah, I have a feeling that it's not my traversal, but rather how I'm storing the triangles themselves in the nodes. It's exactly the problem when I did this method earlier. This was exactly the problem. So I don't think my traversal is the problem. Hey, what's up, Sophie? No, I don't think my traversal is the problem. Is this the correct... Is that the correct math? I have an old version of acceleration that I can check to see if the math is correct. It is parent first index plus parent count minus 1, so that is correct. And then at the end I did if left count equals 0, then return. Which I do now. It's I minus parent first index. Sorry. I'll close the window. Maybe there's something that I don't understand about this. Maybe it's how I exit out. Maybe this, but you know, this just splits forever if I leave this. You think you're gonna go to sleep? Alright, peace out. Thanks for hanging. I need to make sure that they don't get the same. I need to make sure that they don't get the same indices. I need to make sure that they all get different indices. They do. It does split properly. I wonder if it works if I just do this. If I just go back to how it was before. But I think that this is just going to make them sized evenly. Or maybe not. Oh. Oh, but this doesn't work either. I'm just seeing if where I go through the floor is where no node is found or what. Nah, it seems to find it. Just doesn't have the triangle inside of it. God, I had this acceleration structure working, but then I decided to change it because of the ray tracing. Yeah, get stuck. If left count equals 0 or right child dot count equals 0. Made the first version of your Zig project? That's cool. What is it on? Okay, so we have 0 collision here. Let's make sure that we're not using left indices count at all. It's called Giz? That's funny. Maybe my traversal is wrong and I'm getting the wrong nodes. Or actually, you know what? I think I realized the problem. I think I'm supposed to I think the bounding boxes might overlap between them. And so I shouldn't just return them. I should process things inside of them. Because I could return multiple ones. Because it's not just one node that we could find. If I wanted to test this theory that I have out, how would I do that? Or are we supposed to just get one node? Enough Celeste. I haven't never played that game. Okay. So if this node left is -1 and the node right is -1, then we have to process the node here. So we're gonna call this process collision BVH and just do it inside of there. Do everything inside of here. Alright, so for here we're gonna need a mesh, the BVH node, and the proposed, and also the mesh node. How's it going? It's going alright. I really didn't want to work on this today, to be completely honest. But that's fine, I guess. We don't even use TR, do we? No, we don't. So instead, let's call this P. Oh, wait. Oh, this is, we need collision points P. There we go. We don't need to return out anything. We just process the collision node here. Yeah, this is a mess. Do you want to make this an everyday thing? Do you consider taking a break? When I start programming, I don't really take breaks. I take breaks that are like maybe like a month-long break every few months, but then I come back and I do it every day. Yeah. I don't really have the ability to do that. Because then on my days off, I just don't really have the ability to calm down or anything like that, you know? Okay. 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 So this function traverse collision BVH. Why is this not giving me an error? Oh, because I need to change it in the header, that's why. Yeah, it's kind of a pain in the ass because unless you find a way to pass function pointers into this, you have to make dedicated functions per BVH. Someone beat you to this idea? Yeah, that sucks. I don't know. People have said to me before that it's like unhealthy, the obsession I have, but I think that it's just the way I kind of have lived my life, whether it's programming or not, is that I get very dedicated to the things that I do. And then when I need to take a break, I take a long break. Alright, let's see if we did this correctly. Sometimes my day would only consider the programming. Yeah. I don't really do anything when I'm not programming. Okay, it looks like I did it correctly. Nice. Okay. Thank God that wasn't hard. I would have like lost my fucking shit if it was hard. Okay, we still do fall through the floor though, but that might be just a general collision problem. Like we have had that collision problem before. Just the way the janky collision works right now. But this seems to be fine. If anything, we can resize the AABBs to be a little bit bigger. But this traversal is now way faster, like way faster, because it's proper BVH. Yeah. When I take my breaks, I usually like either get a job or just, you know, play video games or whatever, or watch movies. Yeah, I don't think that that's just that's a traversal problem. I'd hope not. I just want to make sure that it's good now before I do all this extra code that I'm going to have to write here. Which is going to suck. Not going to lie. Not going to lie, it is really going to suck. Yeah. It may be this if call return thing. I'm not gonna worry about it since the collision was already pretty janky before, not gonna lie. Alright. Moving forward, so the whole purpose of me fixing the BVH to be like proper BVH behavior is that now I wrote these notes in here that are we now have to code, which is this ray intersects AABB and how it traverses with a ray into the BVH. This is what makes a BVH fast, is the way that we can raycast through it. It's actually technically ray tracing, but yeah. Can't wrap my head around any of this engine things for large projects. Thanks. It's not that hard. I think it's just you have to spend a lot of time doing it, you know what I mean? It doesn't, it's not really about the amount of effort or about the amount of skill. It's just a lot of time that you have to spend with your head in it, you know, and then you get it. Something else that we need to do, actually, now that I think of it, is we also have to make the scene BVH a proper BVH as well, which sucks. The good thing is that it's pretty much the same exact code anyway, so it's not like a big deal at all. Just gonna get rid of this extra stuff here. It's not a big deal at all. We just have to adapt it for the scene rather than the meshes. But this is important because this is also going to matter because we're going to be traversing both the same exact way. Trying to make one after putting myself through years of college and a bunch of books. Yeah, you're probably starting from a much better place than I did. That's for sure. Oh wait, fuck, this is the wrong function. I just woke up one day a long time ago and I just said, hey, I want to make an engine. I didn't really put that much thought into it. I didn't know that it was going to be hard. I just was like, you know, I had a dream about this like horror video game that I was playing, and I was like, man, I want to make something weird like that hasn't really been made before, and then I made an engine. But yeah, it was a lot of shit. A lot better now at coding graphic stuff than I was back then, so that's good at least. Right, we have to do this, which is annoying. Oh, our translate ABBs don't have... Oh, right, they can't. Or, yeah, they can't actually have rotation in them. I forgot about that. We may have a problem with that later, but let's not even worry about it. To set that up here. Or actually, no, we're not supposed to have that anymore. Just like one time you decided to make a chess engine. Yeah, that wasn't really my first chess engine. I made my first chess engine before the game engine, before I started on the game engine. I made it in Rust. And it wasn't very good. I just like had done the Rust book and I was like, okay, well, chess engine seems like a cool thing to do. But when I got down to it, like, I realized in chess engines, like, it's so easy to make a chess engine, but it's really hard to make a strong chess engine. And a problem like that is something that I really like, you know. I really like I don't know. I really like it when something is, like, easy to do a decent way, but then really hard to do a really good way. Like, that's a challenge that I really fucking enjoy. And that's why, you know, you can look up chess engine videos and stuff like that, and it's like people building an engine in Python in like a week or whatever, and it's like, that's not a chess engine. Or it's like, that is a chess engine, sure, but it's like, I don't want to sound like a gatekeeper or whatever, but it's like, it's not... You get what I mean. It's like, a chess engine is such a deep, like, conceptual, like, mathematical thing, and it's a thing that you can build to have personality, like, you know, like your own personality. It's like a brilliant thing, and I just saw like so much like chess engine content that was just fucking slop. You know what I mean? And so that's when I went back and made the second chess engine. That's what the purpose of it was. That's what the purpose of it was. Perhaps what they made only stop to the surface level. Yeah, I think that's just very common with, like, you know, I don't want to sound like a dick or whatever, but like younger people's projects is like very common. It's like, you know, something that like is a cool idea, a cool concept, and it works, but it like isn't great. You know what I mean? Like for me, anything that I've made, I've like tried to push it to being at least like a great thing, you know? 'Cause I don't want to like put something out there that isn't like, I don't know, that doesn't represent like the full sort of, you know, you get what I'm saying. Scope of what I'm capable of, but you know. The only thing we're missing now is the hard part, which is the obviously the ABB resizing. Don't want to make things half-heartedly. Yeah, exactly. When I commit myself to a project, I mean, it takes over my entire life. I think that that's what it's supposed to do. At least, like, that's how I wish, like, people made things in general. I think a big problem right now is the reason why things barely work and are, like, you know, programs are so slow is because people just don't have the focus to, you know, make something, like, seriously, like, really commit to it, you know? I'd rather just, like, ship it and then make money off of it, whether it is great or not, you know? Yourself through head bobbling stuff like this, though. Yeah. Yeah. I mean, the main thing is just to... The main thing is to just, I don't know. Sorry, I'm trying to focus right now. I think you can definitely like toy around with things like in projects on my own, right? Like my own projects that I've had, like I've definitely had some things where I just toy around for a bit and learn something and then move on, right? Like for example, that the space project was kind of just like me toying around with stuff. But it's like, you know, that stuff is like not what I want to like be define me, you know what I mean? The money making stuff. Well, I think that that's where the thing comes from, you know. That's where it comes from. Is that everybody just wants to show off or make money or whatever, you know. But I don't think people actually like care about doing great things, which, you know, it deeply bothers me because I feel like that's I've had so much like happiness and enrichment in my own life, like just like me talking like personally about like how I perceive myself and my own like self-worth and self-esteem. Like it makes me so happy to like dedicate myself to something and get better at something over like long periods of time. Like we're talking about like years of my life coding, like just coding, like not doing anything else, but just like sitting here and coding every day, you know? It's like I've gotten so much happiness out of that, right? And I feel like most other people just like don't have maybe like the ability to do that. I don't know. But it took me a long time in my life to get to that point. Like when I was younger, I would like watch YouTube videos and then like maybe spend like a week or a month on something, right? Like on working on like some music that I was working on or some art or something, right? And then, you know, somebody would tell me something and then I would try that out and then, you know, and then I got into college or whatever and then like it was just, but did I really like know anything? Like no. I don't think I ever really like how I know programming now, how I know C. Absolutely not. I had no idea what I was fucking, you know, doing, just because I didn't spend the time. I just didn't put in the time. Even though on paper maybe I spent the time. Like, I obviously spent time to be able to study something, right? But I only spent the time required, you know? Like the time when I was in the studio, the time when I was reading the books, the time when I was writing my projects for school, you know what I mean? The rest of the time, I was just listening to music, going to the movies, going to this, going to that, hanging out with friends and stuff. It's like there's so much downtime that I don't think I ever really immersed myself in music, you know what I mean? To the point of like being in tune with it. Like I never got that because I just was living life or whatever. Maybe this is coming off in like a sort of way where it's like, I don't know, where it's like maybe people are gonna see this and think like this is so unhealthy or whatever, or an unhealthy way of living life or whatever. But I disagree with that. I think it's a very healthy way to live life, to dedicate yourself to something. I think it's very important actually. I think it's very important, and I don't see a lot of people doing that, to be honest. But I think that all of the great, like, programmers, that's what they did. You know what I mean? That's what you do to be great at something. You have to, like, just do it, like for a long period of time. Not it's not a matter of, I think, skill or effort. You just gotta immerse yourself in it for a long time. But anyway, that's just my kind of like philosophy. I was thinking about that like yesterday or whatever. I was like thinking like, man, I was thinking about how many hours in the past like 2 years I've spent programming. Like compared to everything before in my life. Like art and music and, literature and writing and things like this, like all of that stuff, even though I went to school to do that stuff and I obviously like was deeply, informed with reading a lot of books and, I wasn't bad in school or like bad at doing schoolwork. The problem was that I never like really committed myself to it. Like every fiber of my being, What's the point if you aren't able to dedicate yourself to what you like? I think everybody is. Like, everybody is. Like, maybe that's like a ridiculous thing to say. Like, I have ADHD and I struggle with it to some extent. And I also have, I have to take my fucking bucket of lithium every day, so I fully have problems with dedicating myself. Like, trust me. That's why I spent most of my life not doing it until now, But at the end of the day, like, it matters. It matters. And I think everybody can do it. I think everybody can. I just think people don't want to. I mean, dopamine is so important to people, and honestly, making money. Like, making money, being able to pay off debt, like my debt, for example, like that's a big problem for a lot of people. So I get that. I completely get that, And that's why very, very fucking talented people, trust me, I've met them working at retail, working in restaurants, very talented, artists, creators end up just doing nothing with their lives just because they need to get by, I don't think that working 40 hours a week gives anywhere near to enough time to actually like be happy and do something that you love and you care about. Not nearly enough time. Like, we're talking about, I think, like a proper work week should be like 20 hours max, like that's what I think, because at least from all the jobs I've had, you get home tired, you go to sleep, you wake up, you go to work again, you get home, you go to sleep. Like, it's fucking ridiculous, you know? Like, maybe it's better if you have like one of like the upper echelon jobs where like you're like in business, you're in an office, you're programming maybe. But all the jobs that I've had on the bottom, you know, like working fast food, working delis, working retail, you know, it's so soul sucking because all of your time is doing something that gives you nothing. Gives you nothing, you know? And so that's the problem. That, I mean, I think that that's the problem, is the fact that our society is run by money, and money doesn't actually follow great things. Great things, for example, in terms of like things that I consider to be great that have been made, have made zero money. Like, for example, the free, amazing libraries and headers and things like this. Zero money comes out of them. So greatness doesn't create money. Greatness never creates money. In fact, it creates the opposite of money, you know? So I don't think capitalism is all that great because of that reason, you know? But anyway. Long rant. Long, rant. I kind of want to fork this file again because I'm about to fuck everything up. I think I'm going to BCO actually at this point. Okay. So now let's just get rid of all this commented out bullshit because it was kind of bothering me, not gonna lie. Okay. So we have traverse collision BVH, which calls the process collision node. I think we're gonna stop here. What do you mean? Did I scare you with the rant about? Traverse. We're gonna call it traverse scene BVH. Like, what I've been thinking while I'm writing this stuff is like maybe we return a stack of integers to all the nodes that we need to process. Therefore, we don't have to call. Afraid I'm asking too much. Or you may be distracted. Oh no, it's fine. If I went live to be productive, then you know I wouldn't go live, or you know what I mean. I think that it does make me less productive just inherently, and so I don't really, you know, bother it that much. Instead of, this isn't going to be in a loop, by the way. We're just going to pass in the ray. Yeah, I think I want to get a stack back of all of the nodes. But the thing is that stack is going to have some limit. Which means that we're going to have to do some code. We're going to have to do some code. Okay. Int, let's have a const int node limit. Let's have two different scene node limit. And we'll have it at 128. This means that the amount of leaves that we can get with one ray. Wait, no. No, you don't want to do that. You don't want to do that. Yeah, because you might get a lot of fucking leaves with one ray. You may get a lot of fucking leaves with one ray. And we don't really want to vector because that's slow. Nah, yeah, I think you have to make a different function. A different function for each one. Yeah, I think that that's what needs to happen. Traverse scene BVH. Ray traverse scene BVH. Lighting. It sucks. It really fucking sucks. I know. But, you know, there's really not much that I can actually do to avoid it. So, let's just move on here. Okay. So, we are going to take in scene data SD. We will take in... We'll take in nodes. We will take in the current node. We will take in, I don't think we need to take in anything else other than the origin and the dir. I think that that's all we need. I don't wanna talk about it. How you broke my heart. And then we'll have an inverse dir so that we can avoid... How about functions that take in any amount of arguments? Can't be... Yeah, we can't. We actually can't because... So to explain what's happening here. With a BVH, you can have... So we're shooting a ray through a BVH. So... What happens is, inside of this function, we need to process the ray at each leaf. Now, you may be saying something like, okay, so why not just return an array that has all of the indices of the leaves? Well, I just kind of, you know, thought about that in my head. Well, we would either need to vectorize it and malloc it. I would need to create an arena for this every frame for the light map. Or... we would have to stack allocate it with an upper bound, and we don't really know what upper bound, because if you think about a lighting ray going through this BVH, it might hit 1,000 leaves, it might hit one leaf, you know, so you really have no clue. So actually the fastest and cleanest way to do it is to just have a nested function like this that just does the recursion, and then it's going to call inside of it a process function for processing the node. And then that process function is going to traverse the mesh BVH inside of this BVH. So I thought about it returning out all of the leaves and then processing it separately. It would have been really nice, but unfortunately... it's not reasonable. It would actually slow us down if I did that. So it's not the cleanest code wise. No, it's not. But it is actually necessary, which is, I'm not happy about it. Trust me, I'm not happy about it, but it is necessary. All right. So this ray intersects AABB. We can just copy this. This is the way you do it, apparently. Okay, so we're going to take in AIBB. We will take in vec3 origin and the vec3 dir. Yeah, I don't like functions that take in a lot of arguments, but in this case, it is unfortunately necessary. It is. It really is. Okay, so we want to do this for X, Y, and Z. Fuck. This is apparently the formula. Now, do I know how it works 100%? Kind of, but like not crazy. I just looked it up and it said this is how you do it. Is you just basically, this is like the ray marching thing that I had before, like a DDA sort of thing, but written in a different way, right? You're finding the maximum of the minimum and then the minimum of the maximum to find where you enter into the volume and where you exit. Now, how we get there with this stuff, I kind of get it, but I mean, apparently it has something to do with the slope formula, so go figure. Okay. So apparently, if T enter is greater than T exit, return false. If T exit is less than 0, we also will return false. Otherwise, do we just return true? I may have to look up what that is, if that's correct. Let's think about it for a second. Also, let's make sure, yeah, I did this correctly. So, if it's greater than T exit, the max of the minimum. Okay. Is it y equals ax plus m or linear interpolation? It's y equals ax plus b, yeah. Yeah, it's just a line, you know, a typical line formula or whatever it's called. Which is what this is up here. It's hard to really like visualize what it does though, so I'm not gonna sit here and really try and figure it out too much. So we're gonna do the same. This is the same exact pattern that we already had before, except we're gonna replace that with ray intersects. And this is going to be node A, B, B, origin, dir. Very simple. We're going to pass in inverse direction so that we can do... That's the whole point of that. Actually, you know what I'm realizing? That we don't have to do this point test because we're going to recurse into it anyway. Now, the more fancy way to do this is the typical, like, parallel way with, like, doing a stack, right? I did this as well in the space program where you have a stack and then you put these nodes on the stack as you process them. I'm gonna keep it a buck though, like that's kind of a pain in the ass right now, so I'm not gonna do that right now. But if I ever do want to parallelize it and make it more cache efficient, then I can do that. We could also do the even like the better way of doing that, which is each child stores the parent's right child. So we could do that as well, but let's not worry about it. Okay. So now we have to move all of that into the process function. Or actually, no, we have to also do... We have to do the per mesh one. Oh, fuck. Oh, shit. Is there... No, I don't think that there is. Okay, now I'm kind of regretting not doing the stack of them and then returning them, because now I'm realizing what is about to happen. I'm about to make a ray traverse mesh BVH lighting that is going to get called from here. Yeah. You hate to see it, you really do, but it's actually it's actually going to be faster than if we do it the other way. Maybe later I figure out a better way to do this, but for right now, we're just going to do it this way. And that's just how it has to be. That's just how it has to be. That's just how it has to be. Also, we want to take in the ray hits. Because that's what it's all about at the end of the day. Is at the bottom we have to fill that with the normal. Okay, so this is gonna call ray traverse mesh BVH lighting, and then the mesh that it's gonna be called. Oh wait. This is a for loop. Oh my god. Mesh pointer meshes equals at globals dot meshes. We have to cast vec here. Cast vec globals meshes sd mesh, and then this mesh indexed by the node. Wait, I didn't do a for loop. Oh, I have to do it in here. Less than node count. And then this one, mesh pointer mesh equals meshes indexed by the SD BVH indices indexed by I plus the node first index. Yes. Excellent. And then inside of here, we will start off the recursion with m nodes, because it's just going to be the first one. Then the origin, dir, inverse dir, and the hit. Beautiful. Beautiful. Now this code is going to be pretty much the exact same thing. Oh, we're passing a vector. Oh, well then we simply need to do pointer nodes, m nodes equals cast vec m nodes Okay. So yeah. The code inside is going to be largely the same. It's going to be largely the same. The reason why we can't write this out better is complicated, but it is what it is. Rochdale Outlet is calling me. What the fuck is that? Okay, so how to process the interior of this node? This is where things get a bit tricky, because now we do what's in here. Now we get this, and then we do this. And we can just, we don't want to make another function anymore, because I'm kind of like losing my fucking mind. But, yeah. We don't need this. We're going to go to BVH indices, because that's what we did now. Mesh indices declared here. Oh god, there's a lot. There's a lot of shit. Do our meshes have indices? Because that would be really nice. They do have an ID that we can use. I think that we're just going to use the mesh ID. No. This. ID. Hopefully that ID is correct. We'll check that in a sec. We may also need to pass in the mesh node. For now, we will get the mesh node here. We'll get the mesh node here, and this mesh node will give us all of these lovely things. No member named first index in mesh node. Oh, wait, we're not even talking about that one. We're talking about this node, bro. We're talking about that node. Okay, now we just want to replace out hit with hit with hit, and that's it. That is actually it. We just process it at the bottom here, and then if we find a hit, then we return true. Okay. All right. Well, I don't know about you, but I'm so happy to be alive right now. What do you guys think? What do you guys think about living right now? Because I feel fantastic after writing this code. Never been happier. Okay, so actually this whole function can die. Die. Sorry, that was a bit mean. We don't even need this function. Like, let's just keep it a buck. All we need is the function ray traverse scene BVH lighting. Ray traverse scene BVH lighting. We will give an SD. Do I not have SD here? Let's not even worry about it because right now we only have one scene anyway. So we're just gonna do globals.sd. What? What is your problem? Oh, I called it scene data. Our nodes will be the globals.scenedata.bvh nodes. And then our other nodes, our current node will be the BVH nodes again. Our origin will be pause, and our dir will be dir, and then our inverse dir will be we'll calculate that now. Okay. Inverse dir, and then inside of here we will give hit. We did it. We did it. I'm actually I feel pretty solid on this one. Wait, what are we mad at for, huh? Oh, are you telling me that that's a yikes. BVH node pointer scene nodes equals cast vec globals dot scene data dot bvh nodes. You just found a new solution? What do you mean? No, it's just one function call at the end of the day. It's one function call, but it still has this in it. So it's not a new solution as much as it's just me finishing it. It's just me finishing it. Oh, yeah, we got to make sure that we call the lightmap function because I got rid of that earlier while we were debugging. Generate UV lightmap. Let's see if we segfault. No, we don't, but everything is dark. Seeing the BVH actually work is pretty cool. Okay, so it's all dark, which probably isn't like the greatest thing in the world. We probably did a mistake somewhere. Actually, you know what? We never actually tested the scene BVH. If I'm being completely honest, we could actually just just hard code not to do the scene BVH and just do because we only have one mesh right now. So as long as we just pass in the mesh and the mesh nodes, how do we get the current mesh? We're just gonna do this mesh BVH just nodes given mesh given this time mesh nodes. Let's just check if it's the scene BVH because we never really tested the scene BVH. Okay. Uh-huh. Okay, well now I'm a little bit worried. Not gonna lie, I'm a little bit worried now. And just so that I'm checking, this still works for collision. Okay. Okie dokie. I'm just spitballing. I'm just spitballing. Let's just write ones. We're not getting anything. So this did hit is not doing anything. If I get rid of this, hold on. Okay, so we are correct. It is not working. It is not working. Okay, so let's try and figure this out. Match indices equals MBBH indices. That's correct. J plus node first index. That's correct. We don't have translation. Oh, hold on a second. Hold on a second. Oh no, but we have origin and dir. Hold on. Did I was traversing with PM. And PM was that was transformed by the local matrix, but that shouldn't matter because that shouldn't matter. But technically we should do that. Shouldn't matter though. Because right now we're at starting position. Hold on a second. Hold on a second. We need to propagate this up through the tree. Okay. How do I do that? Do I just return true here? That's probably what it is. Yeah, there we go. Okay, so I wasn't freaking out. I was freaking out for no reason because the code is correct. The code is correct. Oh wait, no. I still have all this commented out. Okay, the code might not be correct still. Fuck. Wait, seriously? I should check what nodes we are. Is this return false bad? Let me try this. Even if I return true through everything, it doesn't work. Measure IDX of 0. Now it shouldn't matter. All we're doing is returning true. Oh, wait a second. Oh, I'm stupid. Wait, but no, because this propagates up to the root. So if I pass in the root, then it should be fine. Oh my god. I'm gonna guess that we hit, but we're not propagating up to the root. Oh, we're not hitting. Oh, hold on a second. Hit T. What is hit T? What is hit T? Did I used to set that to something? Oh, infinity. Oh, I see. Well, then let's just put that here. Okay, there we go. Okay. So I didn't have the T at infinity, so when we were doing the tests over it, it didn't really work, so that's fine. What isn't fine that I noticed is that our underneath is just insanely red. I thought that the BVH would help us in not hitting the bottom side, but we still are just really lighting up the bottom side instead of colliding with the top, which I don't really know why that is. Also, we gotta remove this because that's slowing us down a lot. Even if I do rand bounces, like, look, it totally lights up the bottom. I don't know. I don't know why that's happening. It's so weird. It's like, are the normals wrong? It's like it's hitting itself. Like, if I set it to something large, Let me try hitting the hit index. Yeah, it's lighting itself up. It's hitting itself. And I don't know why that is. If it's somehow our normals that are problematic to some degree, or what. Let me just see this if it's got something to do with this. Oh, whoops. Oh yeah, it didn't do anything. Why would it be lighting itself up if the normal is correct? Let's try something. Let's try basing it off a triangle normal and not the island normal. I already have this based on MF normal. But what if I do my light map, my UV assignment based on the, because I do it based on UVI normal. What if I just print If I split up the the islands with an epsilon of 0 just to see. No. Oh man, what could possibly be happening? What should I even do to debug here? Yeah, it's definitely 0.5. Huh. Let's try not. Oh, I was passing in origin anyway. Let's try not doing any transforms. Still. Do I do a transform up here? I do. No. Oh, wait a second. I think it's actually this. Yeah, you know what? I don't think it's a bug. Huh, maybe it is. Yeah, it might not be a bug. It might just be me being stupid. I think it's supposed to light itself up. So I should probably like undo everything that I just did. I mean, not this stuff, because that was actually what I wanted to do. Okay, let me go to where I make the islands and have that epsilon for, yeah, keep it at that. Yeah, I think I'm just being stupid. But it is true, I needed to pass PM inside of here, which is it translated by the model matrix. And also at the bottom here I need to, yeah, this matrix is being sent. Okay, before I move on, I want to do this multiplied times inverse direction. Obvious optimization. It still works. Okay. Yeah, I'm not actually sure why the bottom is It's difficult. I might have to figure that out later. I just don't understand why that would happen. It may be my ray intersects triangle test. I don't really remember how this works. Yeah, I might have to look up to do a better one. Maybe that's the problem. Because the normals of that stuff can't be wrong because the collision works correctly on them. So I'm not really sure. Anyway, moving on with our lives for now at least. So our patches, right? We have our patches, but we never actually did anything with them. And so we have our patches, and now we're gonna have a vec3 pointer front. And then we'll have a back. And that will just be our lighting that we're gonna ping pong back and forth. What we'll do per islands per triangle, we will slot into the patches the stuff. So this is where this loop is going to end. And then we'll go through the patches and then do this loop later. Gonna make a random melody. All right. That sounds fun. So we have the position, and so we want to let's get the light map texel. And it's going to be patches indexed by the index. And now within text, we will put the position. We will put the normal. We will put the try. Actually, we don't need the try to do what we're doing. And then the rest we can figure out later. But we do the lighting calc here. Sorry, I just thought I heard something. We are going to need to take in we're going to need to put the barycentric somewhere. I think you do it here, yeah. I don't think you actually need them. But let's just keep them in case, I guess. Okay. And then down here we do this. So from here we want to calculate a directional light. And for now there's going to be no occlusion. So it's just going to be a light going down onto it. So yeah. I copied the function this morning. I don't think we... I think our... I think we'd just do this for a directional light, actually. This is for a point light with attenuation. So this is what we care about. And then this will just be the direction of the light. Because obviously a directional light doesn't have a position. Let's just make it a vec3 so that we can normalize it. So, like straight down. And then we don't have attenuation. Okay. For now, that just goes into text lighting equals this. And now all we do is we loop over the texels. We also, also on texel, we want to just have a boolean active. And we will calc it so that it only is the ones that we set active. Because there's going to be texels that aren't active, obviously. These also will all need to be calc'd. I don't know why I didn't. Just wasn't thinking. Okay. Actually, yeah, let's do actually, no, yeah, this is fine. It's Clanged is gonna get mad at me if I don't nest it. And now we have our texel, and then from here we do our array stuff. We do all of this in there. And then we just accumulate into front and back every time. So this is just going to be in a for loop. We'll just have a we'll do 4 iterations for now. And we're just going to have some nesting. Of course, we could just put it in a function and it would look a lot cleaner, but for now, we just don't give a shit. We're going to do 12 rays. Something else we want to do when we determine the texel at the end here, we want to check if we want to get a light map texel if not text active, continue. Very simple. And this will be called hit text. Okay. And then over here, we will have we'll say vec3 pointer temp equals back equals front equals temp, just swapping the pointers, like, because back is gonna write from front, and that you get what I'm saying. So we will always be sending it, since we start on front, do we actually need front and back? What is the formula? That's the formula. But then why are we... Why do we need a front and back buffer then? I don't think that we need a front and back buffer. Let me look this up. I didn't really think about this. Okay, so it's only a GPU thing. That makes sense. Okay, so let's not even worry about a front and back buffer then, since we aren't on the GPU yet. That is what I was worried about. Yeah, so that's fine. We need to get the mesh nodes. Okay. So now hard coding stuff. So what you're telling me is that this is Am I supposed to be dotting R normal with the hit text normal? That's what I'm wondering. Like that makes sense, right? Like I thought that was the idea. Actually, you could just use UV buffer. Alright, now how long is it going to take for this to run? That's the question. We could parallelize it very easily. It literally does just parallelize very easily. Okay. So this once again is what I was worried about, because we don't get anything on the top. And obviously it's low resolution for testing purposes. Like that goes without saying, right? That was 4 iterations. Okay, so this is what the problem is, that the light dir should be 0.8, I believe. Huh. You can make it look good without iterations by just simply increasing the texel resolution, which is really low right now. Why do I feel like the normals are broken or something? They shouldn't be, but... I'm doing this right, right? If I don't scale by normal, what does it look like? The bottom is what I expect the top to look like. I think the only way to debug this might be to actually like make every triangle its own UV island. The only reason this is happening is because rays are coming from the other side and then going through. Wait, hold on a second. I never actually I just return. I don't check the entire array. I just return true. Okay. I need to find the first hit triangle, not the... I need to find the one with the lowest T. Okay. That's probably what's happening. Okay, well, I can fix that. Hit, ray hit. No, that just made it worse. That just actually made it worse. That just actually made it worse. What the fuck are you talking about, bro? What? Oh my god. Yeah, I don't know. I don't fucking know. this really what it's like is supposed to look like? I don't think so. Fuck. Let's try going into hit. Oh, you know what? Hold on. We don't actually push out by the normal at all. This is like, it's supposed to be this way for the other side. Bro, like... I want to get rid of all of the things that could be causing this problem. Like all of the transforms and shit. Like, I don't know. The thing is that this was happening before, so... Hold on. No, that wouldn't matter. That wouldn't matter. Since it's only one mesh anyway, it would not matter. I just want to see how far away it is. Huh. It's just not hitting the closer position. Or maybe not. Because we're hitting the All right, let's do this. Let's see pause versus hit pause. We also need to see normal dir. All right, let's sit down and work this out, huh? So we start at this position. Hit pause is at this position. The normal is, so this is on the other side. And the dir was 0.3, 0.6, 0.6. So that's not even a negative z. Oh wait, no, yeah, so it is. So it is hitting itself. Huh. Maybe I do need to have a negative, a positive. Maybe it does need to be negated. Hold on. Yeah, I think it does. I think it does. I think I'm not tripping. But this is interesting. Like, why? Why this face? Why does it get so much light? Shouldn't the flatter surfaces get more light? Doesn't really make sense to me. Like this should, that just, yeah. Huh. And isn't this bias thing, is it? No. Yeah, this is so strange. This is so strange. I don't. I just want to see what it's like with random rays. It's like truly random rays. Oh, okay, so then it's definitely my bounce generation logic. This shit takes forever to bake, but could probably make it better. You're going to sleep? Alright, peace out. Thanks for hanging. Good luck? Yeah, I will need it. I will fully need it. Yeah, the stuff over here doesn't get bounces. I wonder if I need to just like initialize it to something rather than just have pure bounce. Like if I go into buffer index and set it to this in the first place. Oh wait, I'm so fucking stupid. Oh wait, no, I am adding. I'm not crazy. I'm not crazy. What did I do? What? Why did I have... Huh. The problem is that we don't have like bounce, like the ability, like it's not a... Like these are obviously not going to get bounced against anything. Now if we had like a larger thing, it would probably look a lot better. But yeah, that's I think that's why you do something like this, and you at least set it to a value. But yeah, you definitely don't want to do that. I think setting the albedo to the normal would probably be good. Oh wait, but we can do that. We just do... Alright, let's try this out. I should look up how to do it, because I literally just like... I was like, oh yeah, I'm just gonna like look it up and get it, and it'll be easy. But I didn't really like look that deep into it. Cosine weighted rays for light map formula. You can transform this to the unit disks. All right, I have a book. Okay, here we go. Sampling a unit disk. I feel like I've done this before. How do I do this in 3D? Sampling a triangle. Sampling cameras. Constant 2D. Yeah, they don't have it in 3D here. I can probably transform it to 3D though. Cosine weighted hemisphere sampling. So concentric sample disk. Okay, well, oh, this is what I have. This is what I already have. It's r times cosine of theta, r times the sine of theta. And I do r equals the square root of u0, u1. This is a uniform sample disk. And then to cosine weight it, you take that, and then you, the max of 0 and 1 minus yeah. So all it is okay, so all it is that's it. So that's I feel like that's see, and now this side just gets completely fucking blown up, which doesn't really make any sense. Maybe you have to, oh, maybe it's, you have to transform it by the normal. Hold on. Because the normal doesn't actually do anything yet. Transforming cosine weighted ray by normal. Does this show me anything? You must rotate it into tangent space. Transform. You need tangent space ray by this basis. I need cross and the tangent vectors. Okay. This is fucking crazy. Okay, I mean it's not crazy. It's not crazy. It's fine. Okay. We have to okay, so this dir that we get is not actually doesn't actually mean anything yet. We have to transform it by the normal. And to do that, we need the tangent, right? So we have to do that. Didn't really expect to be writing this today, but that's whatever. I believe that this is what it is. It's just that, and then I should make formulas that do this. I believe that that's what we're doing. I believe so. That's what the Google overview is telling me. That I need the tangent and the bit tangent. Normal times tangent, and then construct your transformation using these three vectors. Ray world. The tangent, the bit plus the normal of each one. X, Y, and Z. Tangent dir.x times the tangent. I'm so fucking confused. Okay. 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 Okay, so oh, you hate to see it. You hate to see it. You hate to see it. I hate 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 it. I think that this is what it wants me to do. Okay. So now we need to multiply. Do I have this? I would love it if I have this function already. Uh in the old engine. Oh my god, my eyes. Fuck. Where would this be? Probably in camera. Mole. Oh my god, I have it. Oh yes. Yeah, 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 yeah. Yeah, 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 yeah. You already know what's going on here. You already know. Wait, I already have this function in this engine? No, you're lying. Oh, you're not lying. Okay, I'm the happiest guy on the planet, to be honest. So dir equals tmat mat 3 molvec 3 tmat dir. Am I the happiest man on the planet? Maybe, maybe, maybe. Okay. Please let us be done with this. I don't want to do this anymore. Please, 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 please. Oh my gosh, is it over? I think it might be over. Oh my gosh, I think it's over. I think it is officially finished. We are done. We are done. We are done, 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 done. All right, that's what lighting looks like. Yes, absolutely. Okay, it's pretty bright, you know. It is pretty bright, and there is the padding issues. We already know the padding issues. Okay, why is it so bright though? Oh, this isn't negative. Oh. I mean, that's supposed to, yeah. No, yeah, 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 yeah. Yeah, you're definitely, it is supposed to be. But why is it so bright? Oh, it's because we're doing the normal plus the light still. Bro, it's crazy bright actually. It's like heaven. You got natural occlusion there. Look at that. Okay, but why is it so bright? Uh oh, my foot. My foot is doing the thing again, the muscle spasms again. Fuck off. Okay, I feel like it's pretty bright, bro. But I think that this is like what it's supposed to look like. Kind of, but it's like, it's crazy bright. It's crazy bright. Maybe this is just one of these things where you have to bring the lighting down. I'm not sure. You just like bring the actual light color down. You just divide by some amount after, actually. You just normalize it afterwards. But yeah, obviously the issues with the borders obviously come into play now, but we can fix those. We can fix those. I feel pretty confident that we can fix those. What was I about to do? I was gonna check if the bias thing, if I commented out the bias thing. I did comment out the bias thing. The bias thing is important because it makes it so that we don't yeah, we should definitely turn down the rays for while we're debugging this so that it doesn't take forever. Yeah, I don't think that this is going to be a thing that we can save with barocentric bias. I think it's just something that we have to fix on the UV side. On the dilation side, I have to dilate. But we can do that. We can definitely do that. Glad that we got this working, because I was so confused, but all I had to do was do a Googling. Okay, let's fucking focus up. Lock in. Yeah, dilation has to happen. I think it's a dilation thing. I think it's a dilation thing. My coplanar adjacency thing is, this is a fine epsilon to have. Yeah, I think it's a dilation thing. So how do we avoid dilation? Well, glad that you asked. Or how do we do dilation? Well, glad that you asked, because this is going to be the fun part. I had this before. But that just does a blur rather than an actual dilation. Yeah, like, look at that blur. Like, what? 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 Yeah, that doesn't actually dilate. What needs to happen is that we need to copy into the inactive texels from the nearest good texel. So how do we do that, huh? How do we do that, huh? Well, we could go per triangle again. Just copy this down there. Go per triangle. And then go into the padding. I don't think that we can. How do I get into the padding from here? Min. I could just loop through everything and then just copy. Okay, let's do that. Let's just loop through just like we loop through here. Through Y and X. Through our texels. And then just finish your Sudoku solver. That's awesome. That sounds like some wonderful recursion stuff you had going on. How did that turn out? Good to see you. So instead of if text, we're going to do the opposite. So if text active, then continue. So if a texel isn't active, then we need to copy into it from the closest possible, closest texel. So I need to go in rings out of it. So I need to do an algorithm here. What is the algorithm though? If we go rings, then we could technically just go 3, 5, etc. 3, 5, 7. Three, 5, 7. Do I just want to do that up until you hit the padding? It was trivial, to be honest. It's just a stupid backtracking. Yeah, it's not that hard. Yeah. What about your project? What am I after? That's a deep question. I'm just working on light mapping right now, so I'll show you what it looks like. Right now, it's just so this is just like light is hitting it, right? And so that's what it looks like right now. It's just doing bounce lighting and stuff. But what I'm trying to figure out now is you see these seams. So I need to figure out a way to get rid of the seams. So the reason why these don't get as much lighting is because they aren't facing other surfaces. So there's also that. But yeah, it's low resolution because I don't want to sit here all day baking it. But yeah, that's what it looks like. So I have to, what I'm doing right now is I'm creating an algorithm that goes in the in-between, and then it copies over into the middle, because these triangles aren't actually next to each other in the data, in the arrays. The texels aren't next to each other. Next to this texel is just blank. And that's why when the GPU bilinearly interpolates, it finds just blank next to it. And so what you have to do is light map dilation, where you take the texels and then put them into the blank space that's next to them. So that's basically what I'm doing. I think that there's probably an easier way to do this, but yeah. You could probably go through the island itself, take the rect for the whole island, and then find the border like that from the UVs for that. But that's kind of hard. I don't know how to do that. And then just copy into the padding. I feel like that's probably the way you're supposed to do it. What I was going to do is I was just going to go through every not active texel, just find the nearest active texel, and then just copy that value into there. But probably proper light map dilation, you just go per UV island like this, and then... But how do you do that? How do you do that? Like, you find the min and the max Y. And then you go, maybe I'm thinking about this way too hard. I think I'm thinking about this way too hard. Because we have the light map rect right here. Like, we can just get the light map rect. And this should give us everything we need. I'm gonna open the window. Okay, this should give us everything that we need, because the rect gives us UV width and height, and the padding. So really, all we have to do is take the UVs, find a way to get our texels from those UVs. That's the question. How do I do that? Well, I already kind of have this here. So I could just copy this. So now we're going through the rect height and width. Okay. I had this is code from a long time ago, but I didn't do it right. So, re-explain the main idea from what I recall. It's a game that simulates a society under AI shit or something like that. I'm not sure if it's gonna be that exactly like that, idea. I just have my frustrations with society, and I think I should make something about it. It's not necessarily going to be like AI bad or anything like that, but I don't know. I have a few ideas. I think it's gonna. I have an idea for an RPG where you have these characters that are around you all the time, that are infecting you with disease and debuffs and things like this. And you have like permanent objects that you have to carry around in your inventory that debuff you in battles randomly. Things like this. About an RTS. I'm not like an RTS guy personally. I haven't played a lot of them. Okay. So instead of going through, we want to go into the padding. We want to go into the padding. Fuck, this is confusing. This is fucking confusing. This is fucking confusing. This is fucking confusing. I'm very fucking confused. I'm very fucking confusing. Oh my god. Does the rect width and the rect height have padding in it? That's all I care about right now. Does it have padding in it? It does. It has the padding. It has the padding. So okay, so first thing we need to check if padding is less than or equal to 0, just continue. There we go. Okay, so we need to actually start at padding -1 when we're iterating this stuff, and then go outwards. Actually, no. Actually, no. Let's just do one side at a time. How about that? So let's just do one side at a time. So let's do Y first. Let's do Y first. So this is going to be going down in Y from the top, right? All we need to do God, this is so fucking complicated for no reason. No, we can iterate it. Okay, hold on. Oh my god, this is fucking complicated because we need to be starting at okay, let's just not make it that complicated. Let's just not do it the didactic way. Let's just do it this way. So we need to go the amount of padding in rings going outside. And so every time we're just gonna have this times 2. So int ring length equals j plus 1 times 2. This is some leak code fucking bullshit right now. You all the leak code kids are getting the kick out of this right now. Okay, so no, I'm gonna yeah. It's actually okay. Here we go. Okay, I think I figured it out. Okay, lock the fucking because here's the hard part. Okay, so now we have to delete the middle space, and delete the last ring. We have to not touch the last ring. All we're gonna do is copy in from the middle rings, just in the next one, but we need to delete the middle. We need to not step in the middle. Okay, how do we do that?